Hello, today we'll be starting integration by parts. It is the equivalent formulation of product rule of derivative. Let us suppose that u equals to ux and v equals to vx. They are the function of x, and we want to find the product rule of derivative. Okay, so here's the formula for product rule of derivative. Here's the product rule. Okay, d over dx u times v is fix the first one, differentiate the second, fix the second, and differentiate the first. Okay, this statement can also be understood as differentiation of u times v equals to u times dv plus v times du. So just to understand, you can just think that we are multiplying both sides by dx. So here in this expression, what we need to understand is this d represents the derivative or the differentiation. And now if you switch the sides of this d, then in next side we will have integration u dv plus integration v du. Thus we obtain integration u times dv equals to u into v minus integration v times du. Okay, so here you can see that we easily derive the formula for integration by parts using the product rule of derivative. Here we need to understand that we choose function u to be differentiable and the function v should be integrable. Okay, so let's take a note of it. As we discussed earlier that integration by parts is the equivalent formulation of product rule of derivatives. So here also we would like to figure out the integral or evaluate integral where the integrand is the product of two functions. Okay, so let's take examples. Okay, so here we are taking three examples. The first one is x times cos x dx. The second one is integration of ln of x dx, and third one is x square e to the power 5x dx. In these three cases, we can see that the first integral consists of x times cos x. These are two different functions. Here ln x is a single function. Okay, so integration by parts is a advanced tool which allows us to find the formula for ln of x. Okay, and similarly here you can see that x square is a function which is quite unique to e to the power 5x, and we want to find the integration of the product of these two functions. Okay, to solve all of these problems, we would like to note something. Our problem is to distinguish between u and v as in the formula. Okay, so to recognize the difference between u and v, we have some rule which is known as I-let. Let us go to that. Here in the corner we can see that we have the formula integration u times dv equals to u times v minus integration v times du, and u is such a function which we can differentiate and v is such a function which we can integrate. Okay, so I-let, that's the order of integration that we need to consider. I means inverse trigonometric functions, sine inverse x, cos inverse x, tan inverse x. L represents logarithmic functions, log x with base b, ln of x. A are algebraic functions, 1, x, x square to xn. Okay, so this 1 represents any kind of constant. Okay, so it could be any constant. X, x square, and this all these things or combination of these things will give us algebraic functions. This t represents trigonometric function, sine, cos, tan. E represents exponential function, e to the power x, 2 to the power x. All right, so now let us move on to our example. Here we have our first problem, integration x cos x dx. We now need to recognize which function should be considered as differentiable and which should be considered as integrable. So both functions x and cos x, they are both differentiable and integrable, but we need to recognize them as either u or v according to this order. Okay, so I-L-A-T-E, that's what we use here. This function x is an algebraic function and cos x is trigonometric function. by this order, you can simply see that the algebraic function comes before trigonometric function. So that's why we consider the algebraic function to be differentiable. Okay, and the trigonometric function in this case, which is cos x, is considered to be integrable function. So here we consider u equals to x. Okay, for rest of this quantity cos x dx, we consider that is dv. Okay, so that this integral is of the form integration u times dv. So dv is considered to be rest of the thing except u, okay, which is dv equals to cos x dx. All right, so now let us differentiate u equals to x, since we need to figure out u and du, and also we need to figure out v. Dv is already there, so we need to figure out v from this expression. Okay, so if we differentiate both sides with respect to x, then this would be du over dx equals to 1, and then we can simply write this as du equals to dx. Okay, so that's straightforward. Now let us integrate this one, integrate on both sides. So this would give us v equals to integration cos x dx sin x, right? And here now you can ignore the constant. Okay, later on we will add that. So v is sin x. So let's start integration by part, and so let me copy down the formula, which is integration u times dv equals to u times v minus integration v du. So here, by our assumption of u equals to x and dv equals to cos x dx, so we are considering the form integration u times dv for this given integral. This integration u times v dv would become integration u is x, dv is cos x dx. You can see that u is x, v is cos sin x, minus integration of v is sin x, and du is dx. Now let us integrate the remaining quantity, this one. So this is x times sin x minus integration of sin x is negative cos x, which makes it cos x, and don't forget to add a c. So that's our answer. That's our integration by parts. Second example is integration ln of x dx. So you may not see that there are product of two functions, but we know that if there is nothing, then we can just think this as, so this can be thought of as 1 times ln of x dx. You can see that this 1 is clearly an algebraic function, it's a constant, and ln of x is logarithmic function. So let us consider u to be ln of x. While considering ilet, you can see that logarithmic function comes before algebraic function. Okay, so that's why we supposed u to be ln of x. Then the remaining quantity 1 times dx should be considered as dv. dv equals to dx. Okay, thus we get this form integration u times dv. Now let us differentiate u equals to ln of x. Du over dx is 1 over x, right? Then you can simply write this as du equals to 1 over x dx. So let us integrate both sides, which will give us v equals to x. Okay, v equals to integration of dx is just x. I start the integration by parts. So now if you can realize that this u is ln of x and dv is dx. Okay, this u is ln of x, v is x times x. Okay, just to make sure that we don't get confused with this one, minus integration of v is x, and du is 1 over x dx. So that's 1 over x thing. So we get x times ln of x minus x and x, they get cancelled, so we have integration of 1 dx. x times ln of x minus x and plus c. So that's our answer. Okay, let's go for the third problem where we have x square times e to the power 5x. Okay, x square is an algebraic function and e to the power 5x is an exponential function. By the rule of Eilert, you can see that algebraic function comes before exponential function. So we consider x square to be u and e to the power 5x dx to be dv. Okay. Now let us differentiate u. That becomes du equals to 2x dx, and let us integrate this expression. So this would become v equals to 1 by 5 e to the power 5x. Let's start integration by parts. Then this would be x square e to the power 5x dx equals to u times v. U times v is x square times v is 1 by 5 e to the power 5x minus integration of v is 1 by 5 e to the power 5x du is 2x dx. Okay, so that's all. So then this becomes 1 divided by 5 x square e to the power 5x minus 2 by 5 integration of x e to the power 5x dx. Okay, we can see that the first term is already integrated properly, and the now second term here we get integration of x e to the power 5x dx. Okay, now we again need to use integration by parts for this integral. So x is an algebraic function and e to the power 5x is exponential function. And now for so u would be x and dv equals to e to the power 5x dx. Okay, so simply du equals to dx and dv is v equals to 1 by 5 e to the power 5x. Okay, so that's all. This integral would become integration x square e to the power 5x dx would be 1/5 of x square e to the power 5x, nothing changes in this term, first term, minus 2 by 5 times integration of this whole thing becomes u times v, which is x times v is 155 e to the power 5x minus integration of v is 1 by 5 e to the power 5x and du is dx. So here I have used the formula for integration by parts for this red integral. Okay. So we have 1 by 5 x square e to the power 5x minus, okay, this is 2 times 1 is 2 and 5 times 5 is 25 x e to the power 5x, then negative times negative is positive 2 by 5. So think that I have pulled this 1 by 5 out, and integration of 5x is 1 by 5 e to the power 5x, okay, plus c, don't forget that. Then finally we get the answer 1 by 5 x square e to the power 5x minus 2 by 25 x e to the power 5x plus 2 times 125 e to the power 5x plus c. So that's our answer. Okay, so now let's take some observation in this case. So here you can see that if you have x square, then we integrated this integral 2 times, right, by using integration by parts. So first is this one. Then after that, we again came up with the similar kind of integral, but our power is reduced, right? Here we have x square, and after doing integration by parts once, the power is reduced. And we did integration by parts for the second time. Okay, and we had this answer. Okay, it took us a while to get through all of this. Now imagine what would happen if x cube is there instead of x square. You might have already guessed, if we had x cube, then we might have ended up doing integration by parts 3 times. Okay, so that's lengthy. So we have another easier and quite nice method known as tabular method, which will help us to do the integration by parts. Okay, and it is quite precise and it is well managed, so we will prefer that method over this method. Okay, but it's very important to understand what needs to be done for integration by parts. Okay, see you in another lecture. Bye bye.